Hello everyone, my name is Franco Pucci and I am the technical consultant for the STS Association. I have been involved in the prepayment industry for over 25 years. Welcome to the STS training video series where we will explore all aspects of the STS and the STS standard. I hope you find these videos helpful. In this video we will deal with section 6.4 and 6.5 of the IEC 62055-41 edition 3, Tcdu generation and security function. So let's have a look at the Tcdu generation functions. Those are for class 0, 1 and 2 and it's contained in sections 6.4.3. So the path to generating a token is from the APDU down to the Tcdu, the application process data unit, down to the token carrier data unit. First thing you do is you need to get the 66-bit token data from the APDU. Then you remove 2 class bits and you'll end up with a 64-bit data block. Then you get all the attributes required for you to generate a decoder key and apply it to the decoder key generation algorithm, and this includes supply group code, key revision number, key type, tariff index, international identification number, the decoder reference number, the decoder key generation algorithm, encryption algorithm, and the base date. You then generate the meter key using decoder key generation algorithm 02 or 04, and what you'll end up with is a 64-bit or 128-bit key block. Then using the EA you've selected, you can encrypt the 64-bit data block with the key block using either EA07 or EA11 encryption algorithm, and you'll end up with a 64-bit cipher. You then transpose the class bits and send the encrypted token down to the Tcdu. In addition to that, you could also send, for example, for a paper token, a magnetic card token, you could send the token carrier type, the ID record, and the print record, if you so wish. So now we look at key change tokens in the same light. Again, you have APDU and Tcdu, and you need to get a token from the APDU down to the Tcdu. So you get your 66-bit token data first. You get the new data and generate a decoder key using DKG02 or 04. Now this new data is the new supply group code, key revision number, key type, tariff index, and all the rest of those that you are changing the meter to. Okay, what you do then is take the 32 bits that you get out of that and you replace the new key low order, new key high order, new key middle order 1 and middle order 2, and then you remove the class bits and you'll end up with a 64-bit data block. Then what you do is you take the current data, in other words the current data that the meter is on at the moment, and take the current SGC, IIN, DRN, etc., generate a decoder key using the DKG02 or 04, and you'll end up with a 64-bit or 128-bit key block. You take the data block that you created using the new data, you take the key block you created using the current data, and you encrypt all of that using EA07 or EA11. You'll end up with a 64-bit cipher, and you transpose the class bits once again. 66-bit data is the result, and you send it through to the Tcdu, along with the optional ID record, PRN record, and token carrier type. New key middle order 1 and new key middle order 2 are only for EA11. For EA07 you would only have new key low order and new key high order. The SGC is also transferred in EA11 and in a 3 key change token set. Security functions, you can refer to section 6.5. These are DUTK, DCTK, DDTK key values which may only be generated by an STS approved security model. So you cannot generate any of these keys using any other method other than a STS approved security module. DUTK, DCTK, and DDTK meter keys may only be transferred to the meter using an STS approved point of sale with a security module. And that is for a key change operation. Of course, in a manufacturing environment, it doesn't need to be an STS approved point of sale. It can be any piece of equipment you use, but it must make use of a security module, obviously. A meter may only leave the factory if coded with a DDTK, DCTK, or DUTK, and it must never leave the factory coded with the DRTK. And the reason for that is because the DRTK is the only key that is known in plain text. Continuing with security functions, key change operations. A key change transfers the following parameters during a key change operation, and you can find this in table 50 of the IEC document. It sends the meter key, the key revision number, the key expiry number, the key type, the SGC. Now the SGC will only go in a 3 or 4 key change token set, and the tariff index. All the above must be written to non-volatile memory in the meter after a successful key change operation. A key change operation is initiated whenever one of the following attributes of the vending key change. One is the vending key itself. If that changes, you need to do a key change. The base date, and typically this would result in a rollover key change token set. The supply group code, the tariff index, the key expiry number, the key revision number, the key type, and the decoder key generation algorithm. So if any of those change, the key in the meter must change. Also note that a supply group code may be associated with multiple vending keys during its lifetime. In this case, each vending key will have a different key revision number, and the key revision number can go from 1 to 9. So you're allowed to have up to 9 revisions of a vending key, all belonging to the same supply group code. In the point of sale, key change tokens shall not be generated when the key expiry number relative to the base date is in the past, and you should get a key expired error. So if the key has expired, if you know the key has expired for that supply group code, you cannot generate any key change tokens if it's expired. Key change tokens shall not be generated when the base date associated with the destination vending key or decoder key is earlier than the base date associated with the source vending key or decoder key. Okay, so in other words, if you do a base change from 1993 to 2014, that's fine. If you now want to do a key change to go from a base date of 2014 to a base date of 1993, this is not allowed. A point of sale may optionally generate and issue key change tokens automatically or manually. You could have a system where if any of the parameters we've just discussed change, then the meter is flagged as a future key change, and whenever somebody purchases credit, it'll generate the credit token as well as 2 key change tokens. And this is how it works. Any attributes of the vending key change, then the database of the POS is updated to flag the affected meters with a pending key change. When the user comes to purchase credit with a pending key change, then the point of sale first generates the key change tokens, but the credit token it generates will be encrypted with the new key. What this does is it forces the key change token to be entered before the credit token, because if he enters a credit token without the key change set, the token will not be accepted in the meter because it's still on the old key, and the credit token has been generated on the new key. This is useful to do a customer key change operation without the need for a technician to visit the meter. Rollover key change is an example of where this could be used. This brings us to the end of this part of the video series. I hope you found this video useful and hope you will join us for the rest of the series. So for now, goodbye and see you again soon.